Welcome to our brand new series, Division with 3 Numbers. I'm so excited to start Section 1 with you. Today, we're mastering Unit 10, Calculation Involving 3 Numbers. Let's dive in. Let's look at the preview on page 2. We're asked which expression matches 3/11ths divided by 2 divided by 3. This is our first encounter with 3 numbers. The secret is to use our keep change flip rule twice. When you divide by 2, it's the same as multiplying by 1/2. When you divide by 3, it's like multiplying by 1/3. Look at options A, B, and C. They all change something incorrectly. Option D, however, correctly transforms both divisions into multiplications by using the reciprocals. This is a vital thinking way. By converting everything to multiplication, we can solve complex strings much more easily. So D is our winner. Remember, every division sign can be a multiplication sign if you flip the number that follows it. On pages 3 and 4, we see 2 powerful ways to solve these. Method 1 is the step-by-step approach. We take the first 2 numbers, 9/10ths and 6/7ths, convert them to multiplication, simplify, and get 21/20. Then, we take that result and divide it by the third number, 14/15ths. It's safe and organized. But method 2, shown on page 4, is often much faster. Here, we rewrite all divisions as multiplications right at the start. 9/10ths times 7/6 times 15/14. Why is this better? Because you can simplify any numerator with any denominator across the entire string. It's a huge know-how tip. I recommend method 2 for long calculations to save time and reduce errors. Page 5 introduces a mixed number into our triple number division. We have 7/12ths divided by 5 and 1/4 divided by 2/15ths. The thinking way here is critical. You must convert that mixed number to an improper fraction before doing anything else. 5 and 1/4 becomes 21/4. Now, the problem looks just like our previous ones. We flip the second and third fractions to get a multiplication string, 7/12ths times 4/21 times 15/2. Now we simplified. 7 and 21 become 1 and 3. 4 and 12 become 1 and 3. After cross-canceling, we get a simple final result of 5/6. Never try to divide mixed numbers directly. Always convert first. Now, let's talk about the power of brackets on page 9. Brackets are like a stop sign. They tell you to ignore everything else until you've solved what's inside. In this problem, we have 3/10ths divided by a bracket containing 4 and 1/2 divided by 5/6. If the brackets weren't there, we'd go left to right. But since they are there, we solve the inner division first. 4 and 1/2 is 9/2 times 6/5, which gives us 27/5. Only now do we bring back our starting 3/10ths. 3/10ths divided by 27/5 becomes 3/10ths times 5/27. After one last simplification, we get our final answer of 1/18. Rule of thumb, brackets are the boss. Finally, let's tackle the challenge on page 12. This is a think outside the box problem. We're told that 3 and 1/3 divided by some unknown value equals 1. This means the entire part inside the brackets must be equal to 3 and 1/3. We know 3 and 1/3 is 10/3. So we need to find values for our square and triangle such that square divided by triangle is 10/3. One easy set of values is square equals 10 and triangle equals 3. This problem teaches us that math isn't just about following steps. It's about understanding that 1 is the result when you divide a number by itself. What other combinations can you think of? Maybe 20 and 6? Math is full of possibilities. What a fantastic first section! We've mastered triple number division, mixed numbers, and the boss rule of brackets. Join me in section 2, where we'll mix multiplication and division. See you then. Welcome back to section 2 of our series. Today, we're taking a big step forward. We aren't just doing division anymore. We're going to mix multiplication and division together using 3 numbers. Ready to level up? Let's go! Let's look at the preview on page 13. Before we dive into fractions, let's refresh our memory with whole numbers. Look at these 4 expressions. In the first one, 246 divided by 6 times 15, we simply go from left to right. In the second, 38 times 16 minus 357, we do multiplication first. And look at number 3. Brackets. We must subtract 543 from 678 before we divide. Finally, in number 4, division comes before addition. These foundation rules for whole numbers are exactly what we'll use for fractions. The order of operations is your math compass. No matter how large the numbers get or if they turn into fractions, the steps remain the same. Master these whole number examples first, and the rest of this unit will be a breeze. Keep that brackets first rule in your pocket. Pages 14 and 15 show us 2 ways to handle a mixed string. 2 and 1/7 times 5/8 divided by 3/4. Method 1 is step-by-step from left to right. We multiply the first 2 fractions, simplify, and then divide the result by the third. It's very organized. But look at method 2 on page 15. It's a real time saver. Just like in section 1, we can rewrite the division sign as a multiplication sign by flipping the number that follows it. So, divided by 3/4 becomes multiplied by 4/3. Now we have one long multiplication string, 15/7 times 5/8 times 4/3. This is the ultimate know-how tip. You can cross-cancel numbers across the entire expression at once. 15 and 3 simplify to 5 and 1. 4 and 8 become 1 and 2. It makes the final calculation much faster and reduces the chance of making a mistake in the middle. I highly recommend method 2 for your exams. Let's look at another example on page 16. We have 8/15 divided by 3 and 1/5 times 1/2. Notice the order. Division comes before multiplication here. The thinking way is to stay calm and follow the sequence. First, convert the mixed number 3 and 1/5 into an improper fraction, 16/5. Now, let's use our shortcut from the previous slide. Rewrite the division as multiplication by flipping 16/5 to 5/16. Our new string is 8/15 times 5/16 times 1/2. Now comes the fun part, simplification. 8 and 16 simplify to 1 and 2. 5 and 15 simplify to 1 and 3. After cross-canceling, we're left with 1/3 times 1/2 times 1/2. Multiply the denominators. 3 times 2 times 2 is 12. So our final result is 1/12. See how method 2 turns a complex division and multiplication problem into one simple string? It's like math magic. Now, page 17 brings back our boss, the brackets. We have 8/15 divided by a bracket containing 3 and 1/5 times 1/2. This looks almost the same as the last problem, but the brackets change everything. The thinking way here is strict. You must calculate the part inside the brackets first. Let's do it. 16/5 times 1/2 equals 8/5. We simplify 16 and 2 to 8 and 1 first. Now we have the result of our bracket. Finally, we go back to our starting 8/15. 8/15 divided by 8/5 becomes 8/15 times 5/8. The 8s cancel out perfectly to 1 and 1. 5 and 15 simplify to 1 and 3. Our final answer is 1/3. Compare this to our previous answer of 1/12. The brackets changed the result significantly. This is a huge know-how tip. Never ignore brackets. They are the priority in every math story. Our parrot friend on page 18 has a vital summary for us. When calculating mixed operations, follow these 4 master rules. Rule 1, follow the order and calculate from left to right. Rule 2, do multiplication or division first, then addition or subtraction. Rule 3, if there are brackets, calculate the part inside the brackets first. And Rule 4, rewrite all divisions as multiplications to simplify your life. These rules are the same as working with whole numbers, but applying them to fractions requires extra focus on your reciprocals. I recommend writing these 4 rules on the inside cover of your notebook. They are the key to unlocking every complex calculation in Unit 10. Think of them as your mathematical toolkit. When you see a long string of numbers, don't get overwhelmed. Just pick the right tool from your kit and follow the steps. You've got this. Let's put our skills to the test with the consolidation exercises on page 19. Question 1. 2 and 2/3 times 5/8 divided by 4/5. Using our multi-flip method, we convert everything to multiplication. 8/3 times 5/8 times 5/4. Simplification is easy here. The 8s cancel out. We get 25 over 12, which is 2 and 1/12. Now look at question 2. 13/14 divided by a bracket containing 4 and 7/8 times 1/3. Brackets first. 39/8 times 1/3 simplifies to 13/8. Now 13/14 divided by 13/8 becomes 13/14 times 8/13. The 13s cancel out perfectly. 8 and 14 simplify to 4 and 7. Final answer, 4/7. These exercises prove that when you follow the thinking way and use your know-how tips, even the most complex fraction problems become clear and manageable. Keep practicing. Section 2 is complete. We've mastered mixed operations and the power of brackets. In Section 3, we'll dive into solving real-world word problems using these new skills. See you there! Welcome back to Section 3. You've done a great job mastering the calculations. Now, we're going to put those skills to the test by solving real-world word problems. It's time to see how math helps us in everyday life. Let's get started. Let's look at the preview on page 27. We have two interesting problems. In the first one, we're baking mango cakes. We know 180 grams of flour is needed for one cake, and we have 6 bags of 150 grams each. The thinking way is to find the total flour first, 6 times 150, and then divide by 180. That gives us 5 cakes. In the second problem, a fruit shop is bagging oranges. We start with 482 oranges, sell 158, and then bag the rest in groups of 6. Here, we must subtract the sold oranges first, then divide by 6. This gives us 54 bags. These examples show that the thinking way is all about identifying which operation to do first. Is it multiplication? Is it subtraction? Once you have the plan, the math is simple. Practice these steps, and you'll be a word problem pro in no time. On page 28, we have a delicious problem about orange juice. 3 identical bottles contain 2 and 1/4 liters altogether. Mom pours just 1 bottle into small cups that hold 3/20 of a liter each. How many cups can she fill? This is a classic multi-step problem. Our thinking way starts with finding the volume of just 1 bottle. Since 3 bottles have 2 and 1/4 liters, we divide that total by 3. Look at the bar model. It shows the total amount split into 3 equal parts. Each of those parts is 1 bottle. Once we have the amount in 1 bottle, we divide it by the capacity of a single cup. So our calculation string will be 2 and 1/4 divided by 3, then divided by 3/20. It's a chain of division. Breaking the story down into these 2 distinct steps makes the whole problem much easier to understand. Always look for that first step hidden in the story. Now let's look at the calculation on page 29. We take our string, 2 and 1/4 divided by 3 divided by 3/20. First, convert the mixed number to 9/4. Now, remember our know-how tip from section 1. Rewrite all divisions as multiplications. 9/4 times 1/3 times 20/3. This is method 2 in action. Now we simplify. 9 and the 2 3s cancel out perfectly to 1. Then 20 and 4 simplify to 5 and 1. We are left with exactly 5. So altogether, 5 paper cups can be filled from 1 bottle. This slide proves that even a complex story problem can be solved quickly if you set up your calculation string correctly and use method 2 to simplify across the whole line. Look how clean that math looks when you cross-cancel. No huge numbers, no messy long division, just smart simplification. That's the power of the word problems masterclass approach. Page 30 brings us a measurement problem. We have a roll of ribbon that is 5 3/4 meters long. We cut away 6 sections, and each section is 3/10 of a meter long. How many meters are left? This thinking way is a bit different. We aren't just dividing, we are subtracting a total amount that we've used up. First, we need to find the total length of the 6 sections we cut. That's 3/10 times 6. Look at the orange bars in the diagram. They show those 6 pieces perfectly. Once we know that used up amount, we subtract it from our starting roll of 5 3/4 meters. So, our combined expression is 5 3/4 minus the product of 3/10 and 6. This is where the order of operations, PEMDAS, is vital. Multiplication must come before subtraction. This problem is a perfect exercise in combining different types of operations to solve a single story. Ready to see the final calculation? Let's turn the page. Finally, let's walk through the solution on page 31. We start with 5 3/4 minus 3/10 times 6. First, calculate the multiplication. 3/10 times 6 becomes 18/10, which simplifies to 9/5 or 1 4/5. Now for the subtraction, 5 3/4 minus 1 4/5. To subtract fractions, we need a common denominator. 20 is perfect for 4 and 5. 5 3/4 becomes 5 15/20. 1 4/5 becomes 1 16/20. Oh, look, we need to borrow. 5 15/20 becomes 4 35/20. Now we can subtract. 4 minus 1 is 3, and 35 minus 16 is 19. Our final result is 3 19/20 meters left. This problem was a marathon. It combined multiplication, subtraction, common denominators, and borrowing. But by following the thinking way and taking it step by step, we reached the finish line perfectly. 3 19/20 meters. A very precise answer for a very good mathematician. Section 3 is complete. We've solved problems about baking, fruit, juice, and ribbons. You're becoming a true problem-solving master. In Section 4, we'll continue with more consolidation exercises to sharpen your skills even further. See you then! Welcome back to Section 4 of our masterclass. We're diving deeper into world problems today. We'll learn how to combine everything, addition, subtraction, multiplication, and division, to solve even the most complex stories. Ready to become a problem-solving pro? Let's go! Let's look at Exercise 1 on page 32. We have 14 boxes of candies weighing 11 1/5 kilograms total. We need to find how many 1/20 kilogram bags we can fill from just one box. The thinking way is a two-step process. First, find the weight of one box by dividing the total weight, 11 1/5 by 14. Look at the text. It clearly identifies those numbers. Once you have the weight of one box, you divide that by the weight of a single bag, which is 1/20. So our expression is 11 1/5 divided by 14, then divided by 1/20. Know-how tip: use method 2. Convert to 56/5 times 1/14 times 20 over 1. Simplify 56 and 14 to 4 and 1, and 20 and 5 to 4 and 1. 4 times 4 is 16 bags. Altogether, 16 bags can be filled. Breaking it down this way makes even big stories easy to manage. On page 33, Exercise 2, we're picking strawberries. Dad, Mom, and Bella each picked 1 3/4 kilograms. Then they ate 1 2/5 kilograms together. How much is left? This thinking way involves multiplication and subtraction. First, find the total amount picked by multiplying 1 3/4 by 3. Then, subtract the amount they ate. Our expression is 1 3/4 times 3 minus 1 2/5. Know-how tip: multiplication always comes before subtraction. 1 3/4 is 7/4. Times 3 is 21/4, or 5 1/4. Now, 5 1/4 minus 1 2/5. We need a common denominator of 20. 5 5/20 minus 1 8/20. Since 5 is smaller than 8, we borrow from the whole number. 4 25. 20ths minus 1 8/20 equals 3 17/20 kilograms left. Remember, organized work is the secret to getting these fractions right every time. Pages 34 and 35 bring us a flour problem. We have 17 3/5 kilograms of flour. After selling 4 1/10 kilograms, the shop assistant puts the remainder into 1 1/2 kilogram bags. How many bags can be filled? This thinking way is subtraction then division. First, find the remaining flour, 17 3/5 minus 4 1/10. Look at the blue bar model. It shows the total minus the part sold. 17 6/10 minus 4 1/10 equals 13 1/2 kilograms left. Now we divide that remainder by the weight of one bag, 1 1/2. So 13 1/2 divided by 1 1/2. Convert them both. 27 halves divided by 3 halves. Flip and multiply 27 halves times 2/3. The 2's cancel out, and 27 divided by 3 is 9. Exactly 9 bags. See how the diagram on page 34 helps you visualize the thinking way before you even start calculating? Always look at the bar models. Finally, page 36. Jenna is buying a puzzle for 32 and 4/5 dollars and some storybooks for 16 and 1/2 dollars each. She pays 82 and 3/10 dollars total. How many storybooks did she buy? The thinking way here is subtraction then division. First, subtract the puzzle cost from the total to find the money spent on storybooks. 82 and 3/10 minus 32 and 4/5. Using our common denominator of 10, that's 82 and 3/10 minus 32 and 8/10. After borrowing, we get 49 and 1/2 dollars. Now, divide that amount by the price of one storybook. 49 and 1/2 divided by 16 and 1/2. Convert them. 99 halves divided by 33 halves. Flip and multiply. 99 halves times 2 33rds. The 2's cancel out. 99 divided by 33 is exactly 3. Jenna bought 3 storybooks. This problem combines everything we've learned. It shows that the thinking way is the most powerful tool in your math kit. You've solved a very complex story. Section 4 is complete. You've tackled some very tough word problems today. We've mastered multi-step logic and fraction operations. In Section 5, we'll continue with more exciting challenges. You're doing amazing! See you in the next lesson. Bye. Welcome back to Section 5. You have mastered so many skills, and today we are adding another powerful tool to your math kit, the unitary method. This will help you solve pricing problems like a pro. Let's get started. Let's look at page 37. 3 kilograms of fish balls cost 69 and 3/5 dollars. How much for 5/8 of a kilogram? The thinking way here is the unitary method. First, we find the cost of 1 kilogram. We do this by dividing the total cost by the total weight. 69 and 3/5 divided by 3 gives us 23 and 1/5 dollars per kilo. Now that we have the price for 1 unit, we can find the price for any amount. We just multiply our unit price by the quantity we want, which is 5/8. 23 and 1/5 times 5/8 after converting and simplifying gives us 14 and 1/2 dollars. The unitary method is your best friend in any shopping problem. Find the price for one, then multiply. Pages 40 and 41 test our skills with rolls of string. We're told 3 rolls are 20 and 7/10 meters long. First, we're asked to find the length of 1/3 of a roll. The thinking way is to find the length of one roll first by dividing the total length by 3, then multiplying by 1/3. For the second question, how long are 5 rolls? We simply take the length of one roll and multiply by 5. The key is always to find the value of that single unit, one roll, before you calculate anything else. This makes both questions easy. Always start with the unit. Now for a tricky one on page 42. A box of key rings weighs 5 and 1/8 kilograms. A box of ornaments weighs 2 and 4/5 kilograms. How much do 4 boxes of ornaments and 1 box of key rings weigh? The thinking way here is multiplication, then addition. First, find the total weight of the 4 boxes of ornaments. That's 2 and 4/5 times 4. As shown on page 44, this equals 11 and 1/5 kilograms. Now add the weight of the single key ring box. 11 and 1/5 plus 5 and 1/8. We need a common denominator of 40. After converting, we get 16 and 13/40 kilograms altogether. Breaking the problem down into 2 clear steps, multiplication first, then addition, makes it simple to solve. Always follow the order of operations. Let's finish with the cooking oil problem on page 45. Each tin has 2 and 1/2 liters. A restaurant buys 5 tins. After using some, 3 and 2/5 liters are left. How much was used? The thinking way is to first find the total amount of oil, then subtract what's left. Total oil is 2 and 1/2 times 5 tins, which equals 12 and 1/2 liters. Now we subtract the leftover amount, 12 and 1/2 minus 3 and 2/5. Find a common denominator of 10. That's 12 and 5/10 minus 3 and 4/10. The answer is 9 and 1/10 liters used. This problem shows how to work backwards from what's left to find out what was used. You're becoming a real math detective. Section 5 is complete. You have officially mastered the unitary method and solved some of the most complex multi-step problems yet. In Section 6, we will continue with more advanced challenges. You are ready? See you in the next lesson. Bye. Welcome back to Section 6. We are halfway through our masterclass and you've already mastered the unitary method. Today, we're going to tackle even more complex stories, including some where we have to decide if a fraction even makes sense. Let's dive in. Let's look at page 46, exercise 2. We have 7 bags of rice flour weighing 19 and 1/4 kilograms total. Mom takes just 1 bag and uses 1 3/10 kilograms. How much is left? The thinking way starts with finding the weight of 1 bag. Divide the total weight by 7. 19 and 1/4 divided by 7 equals 77/4 times 1/7, which is 11/4, or 2 3/4 kg. Now, the second step, subtraction. We take that single bag weight and subtract what Mom used. 2 3/4 minus 1 3/10. We need a common denominator of 20. 2 15/20 minus 1 6/20 equals 1 9/20 kilograms left. Know-how tip. Always verify if you need the total weight or just the weight of one item before you subtract. Breaking it down into these 2 steps makes the answer crystal clear. On page 47, exercise 6, Thomas is sharing 11 table tennis balls among 4 people. We're asked for the quantity each person gets. Mathematically, the thinking way is simple. 11 divided by 4. As a fraction, this is 11 over 4, which equals 2 3/4. If we just look at the numbers, each person gets 2 3/4 balls. But wait, can you actually give someone 3/4 of a table tennis ball? This is a vital know-how lesson. In some problems, a fractional result is perfect, like kilograms of flour or liters of juice. But for items that can't be cut, we need to rethink our result. This slide shows the math, but the next slide will show us the logic of the real world. Always ask yourself, can I cut this item in real life? If the answer is no, we need to use a different way to express our answer. Now look at page 48. Our friend in the speech bubble gives us a major know-how tip. Each person gets 2 3/4 table tennis balls is not reasonable. In this case, we must use whole numbers and remainders. 11 divided by 4 equals 2 with a remainder of 3. So each person gets 2 whole table tennis balls, and 3 balls are left over. This is a crucial distinction in word problems. When you're solving a test, always check the context of the problem. If you're sharing balls, pencils, or people, use whole numbers. If you're sharing cake, juice, or distance, fractions are great. This thinking way, matching your math to reality, is what separates a good student from a great one. Don't let the numbers trick you. Always use your common sense. Page 49, exercise 7. We have 7 liters of soy milk and we want to fill bottles that hold 3/5 of a liter each. How many bottles can we fill and how much milk is left? This is another reasonableness challenge. First, let's do the division. 7 divided by 3/5. That's 7 times 5/3, which is 35 over 3. In mixed number form, that's 11 2/3. Does this mean we fill 11 2/3 bottles? Not in the real world. The thinking way here is to realize we can only fill 11 complete bottles. The 2/3 tells us there isn't enough for a 12th bottle. But wait, does 2/3 mean 2/3 of a liter is left? No, it means 2/3 of a bottle is left. This is a common trap. To find the actual liters left, we need one more step. Let's look at the next slide to solve this mystery. On page 50, we see the know-how for finding the leftover liters. We used 11 bottles, and each bottle holds 3/5 of a liter. So, the milk used is 11 times 3/5, which is 33/5, or 6 3/5 liters. Now, to find what's left, we subtract that from our starting 7 liters. 7 minus 6 3/5 equals 2/5 of a liter left. Look at the difference. Our division gave us 2/3 of a bottle, but our subtraction shows that equals 2/5 of a liter. This slide is a master rule for remainders. Always multiply the whole number of units by the unit capacity to find the total used, then subtract from the start to find the true remainder. It's a bit more work, but it's the only way to be 100% accurate. Master this 2-step remainder check and you'll never be fooled again. Finally, page 51, exercise 8. A stuffed kitten is 1/3 more expensive than a stuffed koala. The koala costs $120. How much is the kitten? The thinking way here is about finding a fraction of a price and adding it on. First, find the extra cost. 1/3 of 120 is 120 divided by 3, which is $40. Now, add that to the original price. 120 plus 40 equals $160. But look at the know-how tip. We can do this in one step. We can think of the koala as one whole, so the kitten is 1 plus 1/3, or 4/3 of the koala's price. 120 times 4/3 also gives us 160. This one-step percentage-style calculation is a very advanced and efficient tool. Whether you do it in 2 steps or 1, the answer is the same. The kitten is $160. Great job combining addition and multiplication. Section 6 is complete. We've tackled rice flour, shared table tennis balls, and filled soy milk bottles while learning the vital rule of reasonableness. In Section 7, we'll continue our Exercise 10 journey with even more advanced challenges. See you then! Welcome back to Section 7. We've made it to the final pages of our booklet. Today, we're going to use everything we've learned to solve some sophisticated group and ratio problems. Ready to finish strong? Let's dive in. Let's look at page 52, Exercise 6. In a computer club, there are 26 members and 14 are boys. What fraction of all members are girls? The thinking way here is to find the hidden part first. Since we know the total and the number of boys, we subtract to find the girls. 26 minus 14 equals 12. Now we build our fraction, 12 girls over 26 total members. Look at the calculation. It shows this exact step. Now we simplify. Both numbers are even, so divide by 2 to get 6/13. Know-how tip. The whole is your denominator, and sometimes you have to do a little subtraction to find your part. 6/13 of the club are girls. Great logical thinking. On page 53, Exercise 7, we have 42 cards. 8 are blue and 9 are green. What fraction are green? This thinking way is about ignoring distractors. The question asks for green cards out of the total. We don't need the blue card count at all. Our fraction is 9 green cards over 42 total cards. 9 over 42. Know-how tip? Always look for common factors to simplify. 9 and 42 are both in the 3 times table. 9 divided by 3 is 3, and 42 divided by 3 is 14. So, 3/14 of the cards are green. This problem teaches you to stay focused on what the question actually asks. Don't let extra numbers pull you off track. Pages 54 and 55 bring us back to Jerry's candies. He has 36 fruit and 27 milk candies. In 8a, we want the ratio of fruit to milk, 36 over 27. Simplify by 9 to get 4 over 3. But in 8b, we want milk to fruit, 27 over 36. Simplify by 9 to get 3 over 4. Look at that perfect symmetry. This is our know-how rule. If you flip the names, you flip the numbers. 4 over 3 and 3 over 4 are reciprocals. Mastering this relationship is a major shortcut. If you solve one part of a ratio question, you've already found the answer to the second part. Just flip it. Ratios are just another way to tell a story of comparison. 4 to 3 or 3 to 4 both describe the same sweet collection. Finally, let's look at the melons on pages 56 and 57. A hammy melon is 1 1/2 kg, and a watermelon is 2 1/4 kg. What fraction of the watermelon is the hammy melon? Our thinking way is hammy divided by watermelon. Convert them. 3/2 divided by 9/4. Flip and multiply. 3/2 times 4/9. Simplify to get 2/3. Now for the final question. How many times heavier is the watermelon? Predict it. Since the last answer was 2/3, this must be 3/2 or 1 1/2. Let's calculate to be sure. 9/4 divided by 3/2 equals 9/4 times 2/3, which is 3/2. Exactly. The watermelon is 1 1/2 times heavier. You've now mastered the peak of ratio comparison. You're ready for any test. Section 7 is complete, and we've finished our first booklet. We've mastered triple division, mixed operations, and advanced ratios. Join me in Section 8 as we start a brand new adventure in mathematics. You're doing amazing. Bye for now. Welcome back to Section 8. You are doing a wonderful job. Today, we're going to learn a new, more direct way to solve grouping problems and then apply it to some very interesting stories about books and stickers. Let's get started. Let's look at page 58, Exercise 9. There are 28 students going to an art exhibition, and 3/7 of them are boys. We need to find how many girls are going. The thinking way for method 2 is to look at the fraction of girls directly. Since 3/7 are boys, the rest of the whole must be girls. 1 whole minus 3/7 equals 4/7. So 4/7 of the students are girls. This method is very clever because it lets us skip finding the number of boys entirely. Look at the bar model. It shows the whole divided into 7 parts. 3 parts are blue for boys and 4 parts are orange for girls. This visual makes it clear that we just need to find what 4/7 of the total is. Know-how tip. In grouping problems, always ask if you can find the target fraction first. It often saves you a whole calculation step. Now let's see the math on page 59. We use our new thinking way to set up a single expression, 28 times the bracketed subtraction of 1 minus 3/7. Inside the bracket, we get 4/7. So our calculation is 28 times 4/7. Now, the magic of simplification. 28 and 7 are in the same times table. 28 divided by 7 is 4. Now we just have 4 times 4, which equals 16. There are 16 girls. Look at how clean this calculation is compared to finding the boys first and then subtracting. Know-how tip. Brackets are your best friend here. They keep the fraction logic separate from the total number until you're ready to multiply. Method 2 is a more advanced tool, and using it correctly shows you really understand the relationship between parts and wholes. Practice this one-step approach. It's a real time saver in exams. On page 60, we have a consolidation exercise. Bella is reading a novel with 84 pages. She has read 2/7 of the book. How many pages are not yet read? This is the perfect time to use our method 2 thinking way. Since she read 2/7, the remaining part is 1 minus 2/7, which equals 5/7. So we need to find 5/7 of 84. Our expression is 84 times 5/7. Simplify. 84 divided by 7 is 12. 12 times 5 equals 60. Bella has 60 pages left to read. Know-how tip. Always check what the question is asking for. Is it the part used or the part remaining? In this case, it was the remaining pages, so finding the remaining fraction first was the smartest move. This slide proves that the same logic we used for people in a club works perfectly for pages in a book. Math logic is universal. Now for a bigger challenge on page 61, we have a pack of 180 stickers. 1/3 are animals and 2/5 are cartoons. We want to find how many of these two types there are altogether. The thinking way here is to combine the parts first. We add the two fractions together, 1/3 plus 2/5. Look at the bar model. It shows the animal segment and the cartoon segment taking up most of the total bar. To add these, we need a common denominator of 15. 1/3 is 5/15 and 2/5 is 6/15. Together, they make 11/15 of the whole pack. This is our thinking way plan. Find the combined portion first, then apply it to the total. Know-how tip. When dealing with multiple groups, adding their fractions first is much faster than calculating each group's number separately. It keeps your work focused and organized. Ready to see the final number? Let's turn to the calculation. On page 62, we see the two-step solution. First, adding the fractions gave us 11/15. Now we find 11/15 of our 180 stickers. The calculation is 180 times 11/15. Simplify. 180 divided by 15 is 12. Now we just multiply 12 by 11 to get 132. Altogether, there are 132 animal and cartoon stickers. This slide also shows us the method 1 way of doing each calculation separately, but notice how much space it takes. Know-how tip. Using the thinking way to find the combined fraction first is like taking a shortcut through a forest. It leads to the same place, but with much less effort. The diagram confirms our logic. The two types combined make up more than half the pack. Always relate your final number back to your original estimate. 132 out of 180 feels right, doesn't it? Great job solving this multi-group puzzle. Finally, page 63 shows us the ultimate know-how, the single expression method. We can write 180 times the bracketed addition of 1/3 and 2/5. This is method 2 for addition. It's the most professional way to write your math. Inside the bracket, we find the common denominator of 15, add the numerators to get 11/15, and then multiply by the total. Just like before, we simplify 180 and 15 to get 12 times 11, resulting in 132. This slide is a masterpiece of efficiency. It teaches us that brackets aren't just for division. They help us group parts of a story together. Master this single expression technique, and you'll be solving complex word problems in seconds. It's all about seeing the whole relationship at once. Take a good look at this layout. It's exactly how you should organize your work for the best results. You've officially finished Section 8. Section 8 is complete. We've mastered Method 2 for subtraction and addition and solved problems with people, books, and stickers. In Section 9, we'll continue our sticker saga and look at the differences between groups. See you in the next lesson. Bye! Welcome back to Section 9. In our last lesson, we learned how to add groups together using fractions. Today, we're going to master the other side of the coin, finding the difference between groups. This is a vital skill for comparing amounts in the real world. Let's get started. Let's look at page 64. We're still with our pack of 180 stickers. We know 1/3 are animals and 2/5 are cartoons. But now the question is, how many more cartoon stickers are there than animal stickers? The thinking way here is to identify that we are looking for a gap between two parts. Look at the bar model. It shows the cartoon segment is clearly longer than the animal segment. The space between them, marked with a question mark, is exactly what we need to find. Know-how tip. Whenever a question asks how many more or find the difference, you are being asked to subtract. We have two parts of the same whole, and we need to find the distance between them. Visualizing this gap first helps you understand why subtraction is the correct operation to choose. On page 65, we see two ways to solve this. Method 1 involves finding the number of each sticker type first, 60 animals and 72 cartoons, and then subtracting them to get 12. But the thinking way for Method 2 is much more elegant. We find the difference between the fractions first. 2/5 minus 1/3. Using our common denominator of 15, that's 6/15 minus 5/15, which equals 1/15. This tells us that the difference is exactly 1/15 of the whole pack. Method 2 is superior because it deals with smaller, simpler numbers throughout the process. Know-how tip. In comparison problems, finding the fractional difference first prevents you from having to do two separate large multiplications. It's all about working smarter, not harder. Let's see how to write this as one clean expression. Page 66 shows the ultimate know-how, the single expression for subtraction. We write 180 times the bracketed subtraction of 2/5 and 1/3. This is the twin of the addition method we learned in Section 8. Inside the brackets, we do our fraction work, converting to 15ths and subtracting to get 1/15. Then, we multiply the total by that difference. 180 times 1/15. Simplify. 180 divided by 15 is 12. So there are 12 more cartoon stickers than animal stickers. This slide proves that brackets are just as powerful for subtraction as they are for addition. They act as a container for your comparison logic. Master this one-step subtraction technique, and you'll be able to solve complex comparison stories with ease and total confidence. Now let's apply everything to a new consolidation exercise on page 67. We have a box of 60 stationary items. 3/5 are pencils and 1/4 are pens. Question 1 asks, how many pencils and pens are there altogether? This is our addition practice. The thinking way is to use a single expression. 60 times the bracketed sum of 3/5 and 1/4. Common denominator? 20. 3/5 is 12/20 and 1/4 is 5/20. Together they make 17/20. 60 times 17/20. Simplify 60 and 20 to get 3 times 17, which equals 51. There are 51 pencils and pens altogether. Know-how tip, even with different denominators like 5 and 4, the bracket method keeps your work organized and prevents you from losing track of the total number. It's a rock-solid strategy. Finally, page 68 asks for the difference. What is the difference in number between the pencils and pens? We use our subtraction know-how. The expression is 60 times the bracketed subtraction of 3/5 and 1/4. We already know the common denominator is 20. 12/20 minus 5/20 equals 7/20. Now, multiply the total by this fractional difference, 60 times 7/20. Simplify 60 and 20 again to get 3 times 7, which equals 21. The difference is 21. This slide is the perfect proof of why method 2 is so powerful. Once you've found the common denominator for the altogether question, solving the difference question takes only a few seconds. You've now mastered the complete set of tools for group addition and subtraction. You're a true math professional. Section 9 is complete. We've mastered finding the difference between groups and learned how to use single expressions for both addition and subtraction. You're doing amazing. In Section 10, we'll start our final set of word problems from Exercise 10. See you there. Bye. Welcome back to Section 10. You've done amazing work reaching the final exercise of this unit. Today, we're taking all the tools from your math kit and using them to solve the grand finale problems in Exercise 10. It's time to show off your skills. Let's get started. Let's look at page 69. Questions 1 and 2 are all about triple number division. In question 1, we have 6/7 divided by 9/14 divided by 4/11. The thinking way here is our multi-flip rule. Rewrite both divisions as multiplications, 6/7 times 14/9 times 11/4. Now, the know-how is in the cross-canceling. 6 and 9 simplify to 2 and 3. 14 and 7 simplify to 2 and 1. We get 44 over 12, which simplifies down to 11 over 3, or 3 and 2/3. Question 2 follows the same logic, even with a larger starting number like 3 and 4/7. Always convert to improper fractions first. Mastering this multiplication string technique makes even the longest division problem fast and accurate. It's the most efficient way to handle 3 numbers. Now, look at question 3 on the same page. We have 1/4 divided by a bracket. The thinking way here is non-negotiable. You must solve the bracket first. Inside, we have 5/8 divided by 9/10. That's 5/8 times 10/9. Simplify 10 and 8 to 5 and 4, giving us 25 over 36. Now, the final step, 1/4 divided by 25/36. Flip it, 1/4 times 36 over 25. Simplify 36 and 4 to 9 and 1. Our final result is 9 over 25. This problem is a classic know-how test of your patience. If you go left to right, you'll get a completely different wrong answer. Brackets are the boss. Always give them the priority they deserve. Master this sequence and you'll be the top mathematician in your class. Turn to page 70. Question 4 introduces addition into the mix. 2 and 3/4 plus 2 and 3/4 divided by 1 and 2/3. This is where many students get tripped up. The thinking way is the order of operations. Division comes before addition. We must calculate 2 and 3/4 divided by 1 and 2/3 first. That's 11/4 divided by 5/3, or 11/4 times 3/5, which equals 33/20. Now we add that to our starting 2 and 3/4. Use a common denominator of 20. 2 and 15/20 plus 1 and 13/20 equals 3 and 28/20, which is 4 and 8/20, or 4 and 2/5. Know-how tip. Use your pencil to circle the division part. It reminds you to solve that first. Addition is the final chapter of this story. Questions 5 and 6 on page 70 test your speed and accuracy. In number 5, we have multiplication and division. Remember method 2? Flip the division part and solve it all as one multiplication string. 21/4 times 1/3 times 9/7. Simplify and you'll get 2 and 1/4. In number 6, we have division, then multiplication. Again, method 2 is your best friend. 5/8 times 5/4 times 8/3. The 8's cancel out perfectly. We get 25 over 12, or 2 and 1/12. The know-how here is consistency. Whether multiplication comes first or division comes first, the multi-flip method turns the entire problem into a simple string of fractions. It's the ultimate shortcut for multi-step operations. Practice these until they feel like second nature. Finally, page 71 brings us to questions 7 and 8. Number 7 is a subtraction problem with a bracketed division. Solve the subtraction inside first. 8 and 4/5 minus 4 and 3/10 is 4 and 5/10, or 4 1/2. Now divide by 1/2. 9/2 times 2 over 1 equals 9, a whole number. How satisfying. Number 8 is a multiplication problem with a bracketed addition. Again, brackets are the priority. 1 3/8 plus 6 1/4 is 7 5/8. Now multiply by 2 2/5. 12/5 times 61/8 gives us 18 3/10. The know-how takeaway from this entire section is respect the brackets and know your order of operations. You've now conquered the most complex pure calculations in the unit. Excellent work. Section 10 is complete. You've mastered the grand finale of calculations. In Section 11, we'll take these advanced skills and apply them to final word problems about cabbage, paint, and sugar. You are a math champion. See you then. Bye! Welcome back to Section 11. You've mastered the complex calculations, and now we're applying them to some of the most interesting word problems in this booklet. Today, we'll solve stories about cabbage, paint, sugar, and nuts. Ready to apply your thinking way? Let's get started. Let's look at page 72, exercise 9. A shop owner divides 7 1/2 kilograms of cabbage into 5 equal portions. Then, he divides one portion into smaller bags of 1/4 kilogram each. How many bags are there? The thinking way is a two-step division. First, find the weight of one portion, 7 1/2 divided by 5. That's 15/2 times 1/5, which is 3/2, or 1 1/2 kilograms per portion. Now, divide that portion by the weight of one small bag, 3/2 divided by 1/4. Know-how tip, flip and multiply. 3/2 times 4 over 1. Simplify 4 and 2 to 2 and 1. 3 times 2 is 6 bags. Altogether, there are 6 bags of cabbage. Breaking the story into portion first, bags second makes the logic obvious and the math easy. On page 73, exercise 10, a worker has 3 buckets of paint, and each bucket holds 8 4/5 liters. After using 19 7/10 liters, how much is left? The thinking way here is multiplication then subtraction. First, find the total paint. 8 4/5 times 3. 44/5 times 3 is 132/5, which is 26 2/5 liters total. Now subtract what was used, 26 2/5 minus 19 7/10. We need a common denominator of 10, 26 4/10 minus 19 7/10. Since 4 is smaller than 7, we borrow 25 14/10 minus 19 7/10 equals 6 7/10 liters left. Know-how tip, always calculate the starting total before you subtract the amount used. It keeps your story organized and your answer accurate. Page 74, exercise 11. Each bag of sugar weighs 1 1/4 kilograms. A staff member repackages 6 of these bags into smaller packs of 3/8 kilogram each. How many packs? The thinking way is multiplication then division. First, find the total sugar. 1 1/4 times 6. 5/4 times 6 simplifies to 15/2, or 7 1/2 kilograms. Now divide that total by the new pack weight. 15/2 divided by 3/8. Know-how tip, rewrite as multiplication. 15/2 times 8/3. Simplify 15 3 to 5 and 1, and 8 2 to 4 and 1. 5 times 4 equals 20 packs. This shows how math helps us change packaging sizes efficiently. Remember, find the big total first, then divide into the new pieces. Finally, page 75, exercise 12. 6 identical bags of nuts weigh 1 1/4 kilograms altogether. How much do 7 bags weigh? This is a unitary method problem. First, find the weight of one bag, 1 1/4 divided by 6. That's 5/4 times 1/6, which equals 5/24 kilograms per bag. Now multiply that unit weight by 7, 5/24 times 7. 35/24 simplifies to 1 11/24 kilograms. Know-how tip, even if the unit weight looks like a messy fraction, keep it exact, don't round. The final answer, 1 11/24 kg, is perfectly precise. This unitary method, find one, then find many, is your superpower for scaling quantities. You've solved a great variety of stories today. Section 11 is complete. We've tackled cabbage, paint, sugar, and nuts with our powerful thinking way. You're solving multi-step stories with total confidence now. In Section 12, We'll continue our journey through Exercise 10 with even more shopping and measurement challenges. Keep learning. Bye. Welcome back to Section 12. You've done incredible work. Today, we are finishing up Exercise 10 with some very practical problems. We'll look at shopping budgets, cutting materials, and analyzing usage over time. Ready for the final stretch? Let's go. Let's look at page 76. Exercise 13. Ada has $61.09. She buys a sandwich for $11.50 and wants to use the rest for bread that costs $8.25 a bag. How many bags can she buy? The thinking way here is subtraction then division. First, find the remaining money, 61.09 minus 11.5. Using our common denominator of 10, that's 61.09 minus 11.5, which equals 50.4, or 50.25. Now, divide that by the price of one bag, 50.25 divided by 8.25. Know-how tip, convert both to improper fractions, 252 divided by 42 fifths. Flip and multiply, 252 times 5/42. The fives cancel out. 252 divided by 42 is exactly 6. Ada can buy 6 bags of bread. Organized steps make even a shopping budget easy to manage. On page 77, exercise 14, we have a wooden beam 7 3/4 meters long. Ben saws it into sections of 1 1/5 meters each. We need to find the maximum sections and the remainder. This thinking way is about the meaning of division. 7 3/4 divided by 1 1/5 equals 31/4 times 5/6, which is 155/24, or 6 11/24. The whole number 6 tells us Ben can saw at most 6 sections. But what about the remainder? Know-how tip. To find the true remainder in meters, find the total length used first. 6 times 1 1/5 is 7 1/5 meters. Now subtract from the total, 7 3/4 minus 7 1/5. Common denominator of 20. 7 15/20 minus 7 4/20 equals 11/20 meters left. This two-step remainder check is the secret to perfect accuracy. Page 78, exercise 15. A Chinese chess set costs $40. A puzzle box is 3/8 more expensive. What is the price of the puzzle? The thinking way here is to find the extra cost, then add it. Extra cost is 3/8 of 40, which is $15. So 40 plus 15 equals $55. But look at the know-how tip. We can do this in one step. Think of the chess set as one whole. The puzzle is 1 plus 3/8, or 11/8 of the price. 40 times 11/8 also gives us 55. This one-step method is very efficient for price increases. Whether you find the extra first or use the multiplier, the answer is the same, $55. Great job applying fractions to pricing. Look at page 79, exercise 16A. We have 72 eggs. 1/4 was used yesterday, and 1/3 was used today. How many altogether? The thinking way is to use a single expression, 72 times the bracketed sum of 1/4 and 1/3. Look at the calculation. It follows this exact logic. Inside the bracket, we need a common denominator of 12. 3/12 plus 4/12 equals 7/12. Now multiply 72 times 7/12. Simplify. 72 divided by 12 is 6. Now just multiply 6 by 7 to get 42 eggs. Know-how tip. Adding the fractions first inside brackets keeps your work clean and professional. Altogether, 42 eggs were used. You're doing a fantastic job with these multi-part problems. Finally, page 80, exercise 16B. What is the difference in number between yesterday and today? We use our subtraction know-how. The expression is 72 times the bracketed subtraction of 1/3 and 1/4. Why 1/3 first? Because it's the larger fraction. 4/12 minus 3/12 equals 1/12. Now multiply 72 times 1/12. Simplify. 72 divided by 12 is 6. The difference is 6 eggs. This slide proves how powerful method 2 is. Once you have the common denominator from part A, part B is a breeze. This concludes our exercise 10 word problems. You've successfully solved complex stories about budgets, cutting, pricing, and usage. You're a math superstar. Section 12 is complete. You've solved the hardest word problems in the booklet today. We've mastered multi-step logic and precise remainders. In Section 13, we'll review the summary rules for the entire unit to lock in your knowledge. See you then. Bye. Welcome back to Section 13. You've done the hard work of solving complex word problems. Now it's time to consolidate that knowledge. Today, we are reviewing the master rules of Unit 10. These formulas are the keys to your success. Let's lock them in. Let's look at page 81. Rule number 1. When you divide a whole number by another whole number, you can simply express the result as a fraction. The formula is dividend divided by divisor equals dividend over divisor. Look at the example. 2 divided by 3 is exactly 2/3. The thinking way here is to realize that the division sign and the fraction line are actually the same thing. This is the most basic building block of our unit. Whenever you see a division that doesn't result in a whole number, don't reach for a calculator. Just reach for a fraction bar. It's more precise and much easier to work with in complex problems. Know-how tip. Always keep your answer in the simplest fractional form. 2/3 is already simplified, so it's a perfect result. On page 82, we have rule number 2, dividing a fraction by a whole number. The thinking way is our keep change flip strategy. Fraction divided by whole number equals fraction times 1 over the whole number. We multiply by the reciprocal. Look at the example. 2/3 divided by 3 becomes 2/3 times 1/3. Our result is 2/9. Know-how tip. Every whole number can be thought of as a fraction over 1. So 3 is 3 over 1. Flipping it to 1 over 3 is the natural next step. Mastering this flip is how you turn division into easy multiplication. It's a reliable method that works every time, whether you're dealing with cake, juice, or distance. Practice that flip until it's second nature. Now, for rule number 3 on page 83, dividing a whole number by a fraction. The logic remains the same. Whole number divided by fraction equals whole number times the reciprocal of that fraction. Look at the example. 2 divided by 3/4. We keep the 2, change the sign to multiply, and flip 3/4 to 4/3. 2 times 4/3 is 8/3, or 2 and 2/3. The thinking way here is to see that dividing by a small part actually makes the number bigger. It's like finding how many slices are in a pizza. The smaller the slice, the more pieces you have. Know-how tip. If your result is an improper fraction like 8/3, always convert it to a mixed number like 2 and 2/3 for your final answer. It makes the quantity much easier to understand in the real world. Page 84 gives us rule number 4, dividing a fraction by another fraction. This is the peak of our calculation skills. Dividend divided by divisor equals dividend times the reciprocal of the divisor. Look at the example. 2/5 divided by 2/3. We flip the 2/3 to 3/2 and multiply. 2/5 times 3/2. The 2's cancel out perfectly. We are left with 3/5. The thinking way is to stay consistent. No matter how many fractions you have, the flip the divisor rule never changes. Know-how tip. Simplified fractions are like clean handwriting. They make your work much easier for others to read and for you to check. Always look for those cross-canceling opportunities before you do the final multiplication. It keeps your math journey smooth and error-free. Rule number 5 on page 85 is about logic, using a fraction to show a part of a whole. The thinking way is structural. Use the quantity of the whole as the denominator and the part as the numerator. Look at the table tennis team example again. 18 members total, the whole, and 9 male members, the part. 9 over 18 simplifies to 1/2. This rule is the absolute foundation of all word problems. Know-how tip. If the question asks for a fraction of all, your eyes should immediately search for the total number. That total is the boss number that sits at the bottom of your fraction. Master this part over whole relationship, and you'll be able to organize any group of data into a clear mathematical story. Finally, rule number 6 on pages 86 to 88. The unit for comparison. This is the most sophisticated rule. When calculating what fraction of b is a, b is your unit for comparison and must be the denominator. We use a ratio to show this. Look at the mangoes and pears one last time. If we compare mangoes to pears, pears are the denominator. If we flip it and compare pears to mangoes, mangoes become the denominator. The thinking way is to listen carefully to the word of. Whatever follows of is usually your denominator. Know-how tip. If your fraction is greater than 1, like 3/2, it's usually expressed as an improper fraction in ratios. This shows that the first group is 1.5 times larger than the second. You've now mastered the complete set of Unit 10 master rules. Congratulations! Section 13 is complete. We've summarized all the rules. In Section 14, we'll start our final challenge, the integrated exercise Potluck Party. See you there. Bye. Welcome to Section 14. Today is a celebration because we're attending Bella's family potluck party. We're going to use all our master rules to help them organize their food and decorations. It's the ultimate test of your skills. Let's join the party. Let's start with the mung beans on pages 89 and 90. 8 identical bags weigh 4 4/5 kilograms altogether. First, we need to find the weight of 1 bag of red beans, which is 3/4 of a mung bean bag. The thinking way is finding the unit weight first, 4 4/5 divided by 8, then multiplied by 3/4. That gives us 9/20 kg. In Part B, we find how many pots of soup 1 bag of mung beans can make. We divide the weight of 1 bag by the soup requirement. 3/5 times 10/3 equals 2 pots. Know-how tip. Always verify if you're using the total weight or the weight of a single bag. The one-step method is your best friend here to keep the story straight. On page 91, Mum is making spaghetti. 7 bags of meatballs weigh 2 5/8 kilograms. She uses 1/4 of a kilogram from 1 bag. How much is left in that bag? The thinking way is unit weight minus usage. First, find the weight of 1 bag. 2 5/8 divided by 7. That's 21/8 times 1/7, which equals 3/8 kgs per bag. Now, subtract what Mum used. 3/8 minus 1/4, common denominator of 8. 3/8 minus 2/8 equals 1/8 of a kilogram left. Know-how tip. Word problems like this are common traps. If you subtract from the total 2 5/8, you'll get it wrong. Always focus on the individual item when the story shifts from many to one. Mum's spaghetti will be perfect. Page 92 is all about sandwiches. Bella made 15 cheese and 21 ham sandwiches. Question 3A asks for the fraction of cheese to ham. 15/21 simplifies to 5/7. Question 3B flips it, ham to cheese. 21/15 simplifies to 7/5, or 1 2/5 times. The thinking way here is our master rule of reciprocals. Once you found 5/7 for the first part, you could have predicted 7/5 for the second part just by flipping the fraction. Know-how tip. In ratios, always look for the word of or times. They tell you which group is the denominator. Cheese of ham, ham is at the bottom. Ham times cheese, cheese is at the bottom. Master this word order, and you'll never flip your fractions incorrectly again. Dad is preparing the table on page 93. Each mat is a parallelogram with a base of 27½ centimeters and an area of 572 square centimeters. What's the height? The thinking way is the area formula. Area equals base times height. To find the height, we divide area by base. 572 divided by 27½ Convert the base to 55 halves. Now 572 times 2/55. Simplify. 572 and 55 are both divisible by 11. 572 becomes 52, and 55 becomes 5. 52 times 2 is 104. 104 divided by 5 is 20 4/5 centimeters. Know-how tip. Even with large numbers like 572, the rules of fraction division stay the same. Don't be intimidated. Just convert, flip, and look for those common factors. Dad's mats are ready for the guests. Finally, page 94 brings the donuts. 20 total. 1/4 are strawberry and 2/5 are chocolate. In Part A, how many altogether? 20 times the sum of 1/4 and 2/5. Common denominator 20. 5/20 plus 8/20 is 13/20. 20 times 13/20 is 13 donuts. In Part B, what's the difference? 20 times the subtraction, 2/5 minus 1/4. 8/20 minus 5/20 is 3/20. 20 times 3/20 is exactly 3 donuts. This thinking way, using single expressions for both altogether and difference, is the mark of a true math professional. It shows you see the whole relationship between the donut flavors at once. You've conquered the potluck party. Give yourself a big round of applause. We can't forget the dessert on pages 95 and 96. Mum's jelly is served in cylindrical cups. We see that every horizontal cross-section is a circle. That's the definition of a cylinder. In question 7, we're asked for the weight of 6 cups if one weighs t grams. The answer is simply 6t. This introduces us to algebra, using letters to represent numbers. The thinking way is that the rules of multiplication apply to letters just like they do to numbers. 6 cups times t, weight per cup, equals 6t total weight. Know-how tip: algebra is just math with a shorthand. Don't let the t scare you. It's just a placeholder for a weight we haven't measured yet. You've officially finished the integrated exercise and the entire unit. What an incredible achievement! Section 14 is complete. You've successfully navigated the potluck party and mastered every challenge in Unit 10. You are now a certified word problems master. I'm so proud of your journey. Keep thinking and keep learning. Bye for now.